now we're going to start looking at trigonometric identities, and the first trigonometric identity we're going to look at, like, these are further trigonometric identities. The first one we're going to look at is a compound angle formula, and this is a set of 6 formula that deals with the addition and subtraction of 2 angles in a cosine, a sine, and tan. So addition of 2 angles in a cosine. So if you have 2 angles adding in a cosine, for example, cos A plus B, it's going to be cos A cos B minus sine A sine B. Then subtraction. So you see in sine, in cos, in addition of 2 coses, the sign changes, but you have cos cos minus sine sine. Then for this we're going to have the sign changes to a plus. Then for sine A plus B, it's different. You see, for sine A plus B, it's sine A cos B. Then after you now interchange, now plus cos A sine B. Then you have sine A minus sine B is sine A cos B minus cos A sine B. So you see, for sine, the sign here, it's negative, it stays negative. Here it's positive, it stays positive. But in cosine, the sign changes. Here, where you have subtracting 2 angles in a cosine, it becomes a plus. Here now, what I would love to do is that you have to first maybe pause the video and try mastering this video, or mastering this formulae, or you can do that at the end. But here you have these ones, you have to get them the way they are. Okay, so assuming you've gotten them, or if you haven't, but let's keep on doing. But with time, it's going to stick. So we have now addition of 2 angles in a tan. So addition of 2 angles in a tan, this one we prove it from the above formula. So we have tan A plus B. So this is adding two angles in a sine, but you know sine is tan is sine out of cos. So this will be sine A plus B out of cos A plus B. So what do we say here? We open this, it becomes sine A cos B. Since it's a sine, even the sign stays, plus sine B cos A out of when you're adding 2 angles in a cosine, it becomes cos A cos B minus sine A sine B, and I can say divide through by cos A cos B. So what do I have? I have sine A cos B. I divide it by cos A, because I'm saying I'm dividing everything by cos A cos B, plus sine B cos A. I also divide it by cos A cos B, and this whole thing. Then I again divide everything down. I don't know if this makes sense. I divide everything by cos A cos B. See, I divide everything by cos A cos B. So what happens? So what happens here? Let me see. Some things cancel out. This cancels out with this. This whole thing cancels out with this. So what do we end up having? Here we have sine A out of cos A. So that is tan A. And then this and this goes, plus this is sine B out of cos B, which is tan B out of, this is 1 minus sine A out of cos A, that is tan A, sine B out of cos B, that is tan B. So that is tan A plus B. So we have this. So we've proved, but now this is a trigonometric identity for addition of 2 angles in a tan. This is, so even this, with practice and time, it actually sticks, that you can know that tan A plus B is tan A plus tan B out of 1 minus tan A tan B. So this is for addition. Now you can actually be asked to prove that this, I ask you to prove this, but I've showed you how. Now for subtraction of 2 angles in a tan, I'm going to pause this video and you can try it out. It's almost the same concept. Okay, so finally from this we get, this is tan A minus tan B out of 1 plus tan A tan B. So this is tan A minus B is equals to this. So you see we have this. Okay. Now we've looked at the 6 formulae. Now let's go on. So now the summary of all the formulae we've looked at. First we have cos A. I told you this, them sticking is going to take some time and some practice, but they can eventually. So this is cos A, cos B minus sine A, sine B. See? Then now we have how about cos A minus B? This is equals to cos A, cos B plus sine A, sine B. Then we have what is sine A plus B. This is sine A cos B, but here the sine stays, plus sine B cos A. See, we have sine A minus B is going to be sine A cos B minus sine B cos A. Then I come to the tan A plus B is equals to tan A plus tan B. Now you mastering them in your head helps you. So this is 1 minus tan A tan B, and then tan A minus B. So and is even in the next question is tan A minus tan B out of 1 plus tan A tan B. So you see we have this. Now we have a question here telling us prove that tan A minus B is equals to this. Now this is what we've proved in the previous part. We're not going to do that. And then here it says hence show that this is equals to this. Now this question is going to require us to apply two concepts from what we've covered so far. Now the first thing is you have to know break down to, we're going to say for 15 degrees, get 15. We have to get two angles, like should I call them standard angles, or like they're those angles whose sine, cos, and tan we can get without using a calculator. And what am I meaning? When in our, I think the second video, we showed how to get the trigonometric identities of which we had 60, we had 45, and we had 30. So now these angles, this like for 60, 45, and 30, you can get it tan, sine, cos for each of these without using a calculator. And I may hint about it. I'm just going to hint about it small, but there's a full video on that where I explain how it comes about. So now meaning to get 15 from these, we can either say 45 minus 30, or we can say the degrees, or we can say 60 minus 45. We'll still get 15. Now, me, I'm going to choose. The question wants us to prove that tan 15. It wants us to prove that. So this expression has tan 15. That's what I'm trying to say. Now, for me, how am I going to do it? I'm going to say tan 60 minus 45. And I'm saying this because I know 60 minus 45 is 15. So this is the same as tan 15. Now I'm going to expand this. So this is equals to tan 60 minus tan 45 out of 1 plus tan 60 tan 45. And this is because remember we say this is tan A minus B. So this is from here you see tan A minus B is equals to tan A minus tan B out of 1 plus tan A tan B. So this is the expression we have. Okay, briefly let me talk about this. So what am I saying? I'm saying remember when we talked about these triangles like this, the first thing I talked about an isosceles triangle, no, an equilateral triangle where all sides are equal. We have something like this, and in that triangle all these angles are equal and they are 60 degrees. All sides are equal, all angles are equal, they are 60 degrees. So I said we assume, we just let this be 2. If this is 2, this is 2, and this is also 2. So I divide this like into 2, so I get something like this, where this is 60, sorry, this is 90 degrees, and now this was 2 this side, and this is 1. Can even call this triangle A, B, C, and this is X, just that you can see what I'm saying. This is A, X, and this is C. And now here, since I've divided this into, this becomes angle 30. So you can find this side by saying this is ABC. So this is A squared plus B squared is equals to C squared. What is A? 1 squared. What is B? It's what we are looking for. So this becomes 1 plus B squared is equals to 4. So B is equals to, so this square root of 3. So this is square root of 3. Now from SOHCAHTOA, you can come and say this is 60. So you can come and say the cos of 60 is going to be, you just come and say it's adjacent out of hypotenuse. It's a half. It's a half. Let's confirm with a calculator. Cos of 60, yes, is a half. So you see, so you can also find the sine of 60. That should be opposite out of adjacent, which is 2. It's the sine of 60. Then you come to tan of 60. This is going to be opposite out of adjacent. So you see, we found these angles without using a calculator. Now what am I saying? I'm saying now in this same way we've done this, you can find the one for 30, like you just change the triangle so it will be like this. And now here I want C to be here down. So since C is down, this is X, this is A. Then I can copy the sides. So C is 30, the hypotenuse is still 2, the adjacent of this angle is root of 3, and this is opposite was 1. So I can still come and say what is the cos of 30. I don't know if you get it, and I can find it from here, sine of 30. I can also get the tan of 30. I can also get the tan of 30. Then for 45, let me show for 45. If you're not understanding this, I can refer to that video. We'll get an isosceles triangle, a triangle where we have two parts. So it's not like this. Get an isosceles triangle. Isosceles triangles usually look like that. One angle, these two sides are equal. So this is 90 and this is 45 and this is 45. So we assume this to be 1, 1. Then we label the sides A, B, C. So we say A squared plus B squared is equals to C squared. So 1 squared plus 1 squared is equals to C squared. So this is 2 is equals to C squared. So C will be the square root of 2. So this is the square root of 2. So you can come and now find what is cos 45, that is adjacent out of. And when you confirm these answers, those are actually the cos of 45, sine of 45, opposite out of hypotenuse, then the tan of 45. Now it may be fast, but I'm trying to explain so that we can solve the other number. This is 1 out of 1, and it's 1. So now from this concept, just come and now quote the value. So we can now solve this number. You don't just come and quote your tan of 60. And tan of 60 is root of 3. Then tan of 45 is 1 out of 1 plus tan of 60 is root of 3. Tan of 45 is 1. So I end up having tan 15 is equals to root 3 minus 1 out of 1 plus root 3. Now I look at our proof. What do we have in our proof? You see, we are still very far from our proof. So I can now cross multiply, because this is just, I want to prove it to look like, I can say cross multiply. So we have this into tan 15 is equals to root 3 minus 1. So open this bracket, this becomes tan 15 plus root of 3 tan 15. This is equals to root 3 minus 1. So now I take root 3 where root 3 is. So this one comes inside, so I have 1 plus tan 15 is equals to, this goes this side, I have root 3 minus root 3 tan 15. So I say 1 plus tan 15 would be equals to, I factorize out root 3, this is 1 minus tan 15. Okay, so I have this. Then I can divide through by, now since when I look at the question, I see root 3 is down, so I can divide through by root 3. Since I want to take it down, divide through by root 3, but I can also bring this side. I don't know if that makes sense. Because of space, let me do it on the same working, but you could have done that separately. You want to take it this side, 1 plus tan 15. So I now have 1 out of root 3 is equals to 1 minus tan 15 out of 1 plus tan 15. So I hope this makes sense. The reason I was laboring to explain the other things is such that you can understand why I can just quote tan 60 being root of 3, tan 45 being 1. It's not guesswork. It's because there's a way we can derive them. This was, we can do. Okay, so this was extra space, but it's okay, we'll finish. Okay, now we're going to look at this number. The question says, given that cos A is this and cos B is this, where A and B are acute. So the first thing in these questions, remember that we've done this concept before. So just that the difference is how we will be solving. So we draw, now we have cos A and cos B. So we start with cos A. It's 3 out of 5, but it's acute. So remember we said this is acute. Obtuse, reflex, reflex. This is 0, 90, 180, 270, and 360 if you're repeating. And now here we've said we have cos A's and it's obtuse and it's acute, so we draw the triangle in the acute area, and this is A. It's so capital cos A is adjacent out of hypotenuse, so this is 3 out of 5. Then we have A, B, and C. Then we have A squared plus B squared is equals to C squared, so this is 3 squared plus B squared is equals to 5 squared, so this is 9 plus B squared is equals to 25. So after solving that, what will our value will be? Our value of B is 4. So here we put 4. Then now we can find sine A to be opposite, which is 4, out of the hypotenuse, which is 5. Then we can also find tan A to be, tan A will be opposite out of adjacent. Then now we can come and go to B. So to go to B, we'll draw our quadrant still. Then now this is 0, 90, 180, 270, 360. The question says they are both acute, so acute is here. I draw the triangle. This is theta. So I have cos B is 12 out of 13. And this is adjacent out of hypotenuse. So this is 12, this is 13, this is A, B, C. So A squared plus B squared is equals to C squared. So this is 12 squared plus B squared is equals to 13 squared. So let me use a calculator. 13 squared minus 12 squared. So our final answer of B is 5. So this is 5. So we can say sine B will be opposite out of hypotenuse. Tan B will be opposite out of adjacent. Now solving, this is just quoting the formulas. So this will be tan A plus tan B out of 1 minus tan A tan B. So we just substitute here. Then cosec A plus B will be 1 out of sine A plus B. So this you can now maybe say you first consider, or you first work this out alone, then you substitute later, or you can continue and say this is sine A cos B plus sine B cos A. Then now you substitute and then you solve this. Just come and substitute each of these and you eventually find out. So now just for the answer here is going to be 65 out of 63, and the answer here is going to be 63 out of 16. So we can do that. Okay, now here we have a question saying without using tables or calculator, show that this is equals to this. So first question here is telling us show that tan 15 is equals to 2 minus root of 3. So remember what I told you, that when we have tan of 15 can either be written as tan, so this is tan 60 minus 45, or tan 45 minus 30. So you can choose any of the two. And now I'm going to choose tan 15 to be equal to tan 60 minus 45. So I can expand this to be tan 60 minus tan 45 out of 1 plus tan 60 tan 45. You see? Now, from what I told you, that it's a question even saying without using tables or calculators, so you have to use the other method from last time. So you will just come, I'm just quoting them, but you can even put it as, you should put it as you're working in these questions that show the examiner that you know what you're doing. But for this one, I'm just quoting, but from the previous examples, I think the number where I showed you, I derived each. Then here I rationalize 1 minus this, 1 minus, so this is just now sides. So here what do we have? We have root 3 minus root 3 minus 1 plus root 3. Here I'm opening that bracket. I'm opening this bracket. I brought this in, then now bring this. So this is difference of two squares. 1 squared minus root of 3 squared. And eventually, when you open this, it's going to give you 2 root 3 minus 4 out of negative 2. So you have this. So now you can just factorize out negative 2 such that you have negative 2 into negative root 3 plus 2 out of negative 2. So you eventually have tan 15 is equals to 2 minus, 2 minus root 3. So that is that. Then now the second part, which is tan 75. So tan 75, we express it as a sum. This one we express it as a difference of two numbers whose tan, sine, and cos can be found without using a calculator. So for tan 75, we'll express it as being tan of 45 plus 30. Then I will apply the compound angle formula. Even here, we're applying the compound angle formula for subtraction of two angles in that tan. So this is tan. The other expression, tan 45 plus tan 30 out of 1 minus tan 45 tan 30. Now we can substitute. And I told you we're not just getting these values out of the blue. This is actually how we came up with them using the relationship of a triangle. If you haven't watched that video, you should watch it, either the first video or even just before this. We looked at an example exactly like this. So the rest of this is just factorization. So here you have root 3 plus 1 out of root 3 out of root 3 minus 1 out of root 3. So this is going to be root 3 plus 1 out of root 3 times root 3 out of root 3 minus 1. So here what do we have? We have root 3 plus 1 out of root 3 minus 1. So now the rest of this is just suds. We just rationalize, and because of space, I'm not going to follow through the entire working. Wait, this is supposed to be plus, because this is minus 1, so this is plus 1 as we are putting the conjugate. So you see, now here we can break this down, and eventually we'll have this is equals to 2 plus root of 3. So we have tan 75 is equals to 2 plus root of 3. I hope this makes sense. So similarly, someone can ask you to find similarly, someone can ask you, can be asked to show that sine 75 is equals to root 6 plus root 2 out of 4. So this is something you can try to do. It's the same concept as we've done. Or someone can ask you to show that cos 15 is equals to cos 15 is equals to what? It's also equals to root 6 plus root 2 out of 4. Same concept. Break this down into two like form a compound angle formula, form a compound angle whose angles we can find, let's say 45, 60. We said you're going to use 45, 60, and 30 because you can find the cos, the sine, and the tan of these angles without using a calculator, using the triangle. I showed you we first use an equilateral triangle, find 60 and 30. Then we use an isosceles to find 45. So I hope that makes sense. If you have any questions, you can let me know. Now we are going to look at a few proofs. Yeah, because there are actually very, very many proofs involving compound angle formula. But we're going to look at a few common ones. Then for the rest, I'll show it to you, try it out, then I pause and then I put when we've already done the answer, because we cannot do each and every one of them here because the video would be unnecessarily very long and tiring to watch. So I'm going to introduce the concept with 1 or 2, 3 examples. Then for the rest, I'll just be displaying the answers for you to check yourself to see if you're on the right path.